Hey everyone, welcome back. We're talking about the fundamental counting principle and sample space today. Before we do that, let's introduce Steve. Who is Steve? Steve is our imagination, and we're going to use our imagination to build something called a tree diagram. Steve has a red and blue shirt. All right. He has 3 pairs of pants, simple enough, and he has 2 pairs of shoes. Steve is indeed a clothes horse. This is number 1 at Socrative. Pause the video and see if you can answer that. How many different outfits can Steve make from these clothes? We are going to build something called a tree diagram, and let's start with his 2 shirts and then add his pants. For the blue shirt over here, we would have 3 outfits, and for the red shirt over here, we would have 3 more outfits. That's 6 so far. But wait, we have to add the shoes. These 3 outfits would become 6 when you add the shoes. And these 3 outfits would become 6 when you add the shoes. That's a total of 12 outfits. The answer to number 1 is 12. Here is Steve in all his wardrobes. I mean, what a handsome guy. This is a more simple, traditional tree diagram where you would take the shirts and you'd split them into 2, the pants into 3, and then the shoes into 2 and whatnot. You'd come up with 12 outfits. All right, here is number 2. How many license plates can be made if the last 2 spaces are both digits but can't be repeated? For now, we're building tree diagrams. It will lead to the fundamental counting principle. I mean, this tree diagram has many branches because the first decision that we make has 10 digits. 0 through 9 is 10 digits. Then off the first 10 branches, we have to add 9 branches, not 10 because we can't repeat the 0 here. That's the first branch. And here are all of them. Like right here, we can't have a 5 there, and we can't have a 6 there or a 4 there. You get the idea. And if we were to count all of those, there would be 90 end branches, and that's the answer to number 2. Number 3 is another license plate problem. The first slot is a digit and the second is a letter. See if you can answer that. We're going to build a tree diagram. It's a lot like the last one. So the first part has 10 branches, 0 through 9. Then off each branch are 26 more branches. It would look like this. You can see that that's something that we really don't want to build. We want to use the fundamental counting principle, and there are 260 end branches here, and that's the answer to number 3. Number 4, according to the answer document for quiz A, how many ways can the quiz be answered? Over here is the tree diagram. That would be the first question, and then the second question, and then the third. You can see all of that. And then we'd have to count the end branches. Let's count them. 1, 2, 3, 4, 5, 29, 30, 31, 32. So there are 32 ways to answer that quiz. What if you were guessing? Maybe you're thinking, I sure do like tree diagrams, but I hope there's something better because that would be awfully tedious to draw. Well, here's the something better, the fundamental counting principle. Let's read it. If 2 or more events, what's an event? In this quiz, there were 4 events. Each question was an event. When Steve picked his outfit, there were 3 events, a choice of shirt, a choice of pants, and a choice of shoes, each an event. In this license plate, there were 2 events, a digit and a digit. Each digit picked was an event. And in this license plate, there were also 2 events, a digit and a letter being picked. If 2 or more events occur, the total number of outcomes, sample space, is found by multiplication. You have probably already figured that out. Let's look at sample space as the set of all outcomes for an activity, event, or experiment. Here is number 5. Pause the video and see if you can get that right. There are 7 events, and we should be multiplying 7 numbers. That's them, and the answer is 2,048. Wow, how can you draw a tree diagram for that? Number 6. A quiz consists of 10 true-false questions. How many members are in the sample space? Well, there's 10 events. Each question is an event, so we're multiplying 10 numbers, and the answer is 1,024. It's probably best answered as 2 to the 10th equals 1,024. Number 7, 2 dice are rolled. How many members are in the sample space? The answer is 36 because each die has 6 possible outcomes, and 6 times 6 is 36. But I want to count the tree diagram because I like counting. 1, 2, 3, 4, 33, 34, 35, 36. I mean, can you believe that? 36 outcomes. Number 8, if 3 dice are rolled, how many outcomes would there be? And that would be 6 to the third equals 216. You can do that. Number 9, there would be 6 outcomes for the die, and 1, 2, 3, 4, 5 for the spinner. 6 times 5 is 30. I think we have 3 more problems. Pause the video and see if you can get this problem correct. The fundamental counting principle claims that you multiply these choices, your choices of bread, cheese, and meat. And so the answer would be 3 times 5 times 8, which is 120. Number 11, from this non-standard deck of cards, a card is drawn, not replaced. That's huge. And a second card is drawn. How many outcomes are possible? I want to look at the tree diagram. So if you choose A, you can't choose that A again, but there are 2 A's. So let's look at C. If you choose C, you can't choose C again. If you choose E, you can't choose E again. Now let's just count our end branches. 1, 2, 3, 18, 19, 20. The answer is 20. Think about that for a minute. Last problem of the day, which always makes us happy. Same standard deck of cards essentially, but we're replacing the first card. What difference does that make? Here's the difference. When you draw the A, you can draw the A again. Hard to see because there are 2 A's. Let's draw a C, and then you can redraw the C. And let's count again how many total end branches we have. 1, 2, 3, 22, 23, 24, and 25. Wow, 25. The last one was 20. I wonder why. Guys, I had a whole lot of fun talking with you today about the fundamental counting principle and sample space. See you next time.